It has been a year right now that the Columbus Lab is in orbit in the International Space Station. It's been a very successful year and everything is working perfectly. We are having just standard, let's say, technical issues on orbit, but this is true for all the hardware on board. And we are now preparing for the future, mainly the future experiments to be launched on board the Columbus Lab in the future. With the Columbus Lab on orbit and the Japanese Kibo module just after Columbus last year reaching the space station, we can say that the International Space Station is now really international. After 1 year of Columbus in orbit, we got already a lot of data, and we have distributed this data to our scientists, and they are working on that. So we expect very soon a lot of important results. And in the meantime, we are preparing for the future, so new experiments to be launched on board Columbus. And we expect to make a huge review of these results by mid-2010 for the benefit of all the European scientific community. The importance of the experiments you can perform in orbit and in low Earth orbit in the International Space Station is linked to the absence of weight. And so you can perform a certain kind of experiments only on board and not on ground. And so there are several fields in which you can get a lot. Also for the improvement of the day-by-day life for our citizens. The Columbus Laboratory and more in general the International Space Station is also conceived as a testbed for future human exploration missions. Not only to test the behavior of human beings far away from the Earth, but also to try to test some technologies which can be useful for the human exploration of the solar system. And day by day, year by year, we are increasing the number of activities and the number of technologies we want to test on the space station. And Columbus will be one of the places on the station on which we will perform this kind of activities together with our international partners. The next step in human exploration for the European Space Agency is the development of a re-entry capsule, which has the main goal to transport European astronauts back and forth to the International Space Station for the moment, for the next coming 10 years, and then potentially for a new space station in low Earth orbit. And this will allow Europe to become a real, reliable partner in the future exploration endeavor. And I hope that this will be available in, let's say, in 2020 timeframe.
You've braved adversity. We wish you smooth sailing.
2, 1, 0, and liftoff of Space Shuttle Atlantis as Columbus sets sail on a voyage of science to the space station.
Hey, Steve, it's not too bad. Rex Stan is crossing over to Columbus right now, and he'll stow your bag. Amazing job. We're looking out our window here at Columbus, about halfway there. I can't believe how much work you guys have gotten done on.
Slowly we can see the Columbus module being carefully maneuvered into the ready-to-latch position.
Columbus is touching the station for the first time.
All right. Ooh, great job, guys.
Beautiful work, Leo. We concur for
The home spot if you want them.
Absolutely, we'll take them.
They're in the blue short sleeve shirt, joined by Hans Schlegel in the lower left, also of the European Space Agency.
Excellent day. Looking forward to an exciting EVA tomorrow.
Camera shows him moving along node 2.
About 30 centimeters, please.
30 starboard as we come 2 meters aft.
And we've checked our toolkit, and we don't have the same kind of toric socket.
Of just about over the payload bay of Atlantis with 1,200 pounds plus of control moment gyro and supporting it.
Now flying into an orbital sunrise, a bird's eye view of the International Space Station from the shuttle Discovery. An excellent view from top to bottom. The European Space Agency's Jules Verne automated transfer vehicle mated to the aft end of the Zvezda service module. On the left of your screen, the European Space Agency's Columbus module and the massive Kibo laboratory, the new Japanese laboratory with its robotic arm.
Ah d'accord, donc le bras peut être, lorsqu'il est monté sur ce petit train, peut se déplacer et venir par exemple ici en bout de poutre, ce qui va... So the main objectives of the initial mission of Columbus was of course to launch the module into space and then to fly it to the space station, and then when the shuttle was docked to the space station to start unloading the module from the shuttle payload bay and then attach it to the space station. We have different objectives in the utilization of Columbus, different scientific objectives. One of them is physiology, and when we have a dedicated rack here inside, that's called the EPM. We have another one for biology, that's the biolab, which is right here, and we have here another one which is called EDR and which is used for physics and technology. The last one for European experiments is called FSL and is a laboratory for fluid sciences. Outside Columbus we have currently 2 experiments. One of them is dedicated to the exposure of materials to the space environment, and it's called UTF. And the other one is an astrophysics experiment measuring of the solar activity in different ranges of frequency, and it's called SOLAR, and it's located down there. On a différents thèmes d'expérience. Pour résumer, vous voyez ici, il y a un certain nombre de racks scientifiques qui sont installés. Il y en a 3 européens qui se trouvent sur ce qu'on appelle la partie droite de Columbus et un qui se trouve en haut. Donc les différents thèmes scientifiques qui sont utilisés, c'est la physiologie, c'est le rack qu'on trouve ici, EPM, la biologie sur le rack qui est ici, Biolab, et on a ici, en fait de ce côté-là, un rack qui s'appelle EPM qui est utilisé pour la physique et la technologie, et au-dessus, un rack qui s'appelle FSL et qui est en fait un laboratoire de physique des fluides. Ça, c'est pour les expériences qui sont à l'intérieur. Sur les plateformes extérieures, à l'heure actuelle, on a 2 expériences. Une qui est une expérience d'exposition de matériaux aux conditions spatiales et l'autre qui est une expérience d'astrophysique, c'est-à-dire de mesure du rayonnement solaire.